Hello dear students and welcome to yet another video on question of the day from the actual IPMAT Indore 2024 QA MCQ section. So today's question is based on coordinate geometry and trigonometry combined. So let's see what this question has for us. If theta is the angle between the pair of tangents drawn from the point A, that is 0,7/2, to the circle x square plus y square minus 14x plus 16y plus 88 equals to 0, then tan of theta equals how much? So theta is the angle between the pair of tangents drawn from an external point, right? But before that, we just need to figure out what is the radius of this circle and what is the center of this circle, and a rough diagram will help us understand how we should go about this question. Okay, so if I quickly try to factorize this would be x square plus y square minus 14x plus 16y plus 88 equal to 0. What I would do is, I would pair up the x square minus 14x, so that will become x minus 7 the whole square. I will try to make it that way. So for that, I have assumed an addition of 49 here. So on the RHS also, I'll add up a 49. Okay. Similarly, y square plus 16y. So I'll take it as y plus 8 the whole square. So that will give me y square plus 16y. But I have unnecessarily added a 64. So I'll have to add a 64 on the RHS as well. And there was also a plus 88. If I rearrange all the terms, I get it as x minus 7 the whole square plus y plus 8 the whole square is equal to 49 plus 64. So that will be 113 and minus 88. 88 goes on the other side. So that gives me 25, which is nothing but 5 square. So I realize that the center of the circle, so there's a circle whose center is 7 comma minus 8 and whose radius is 5, because 5 square, and there is a point outside somewhere which is 0 comma 7/2 can be written as 3.5. So this is the point and this is the distance between the center of the circle and the point. And here I also have the tangent. The tangent will be perpendicular to the circle this way, right? This is roughly the diagram that we have. And from this point, we are going to have two tangents. So basically, the other tangent is going to be symmetric, okay? And if this angle is theta, the small angle here that we've got is nothing but theta by 2, because it's completely symmetric. So what I will do is, I will first find out tan of theta by 2, and using that I will try to find out tan of theta. Okay. So for tan of theta by 2, I already have the opposite side. Can I get the adjacent side? So I'll have to use the Pythagoras theorem. For that, 0, 3.5 and 7, minus 8. How much would be the distance between the external point A and the center of the circle? So for that, I'll just calculate the length of AC. AC would be equal to under root of the distance in terms of x. So 7 minus 0, that is 7 square 49, plus the distance in terms of the y coordinate. So minus 8 minus 3.5, so that is minus 11.5 and the square of it. So 11.5 square would end in 0.25 and 11. So basically it will be 11 into 12, that is 132. So 132.25, and that would come out to be, AC would be come out to be under root of 181.25. Now we did not want this hypotenuse actually, we wanted the side, say AP. So I wanted AP. So AP would be what? AP would be the Pythagoras theorem. I'll have to use the Pythagoras theorem to calculate the length of AP. So AP would be AC square minus phi square, that is 25, and the under root of this. So if I do this calculation, I'd realize that AP would be, AC is under root of 181. So AC square is 181.25 minus 25. So 181.25 minus 25, this would come out to be 156.25. Now if you remember squares of numbers ending in 5, the square ends in a 25, and what comes in front of 25 is, so for example, A5 the whole square is 25, and what comes ahead of 25 is nothing but A into A plus 1. Okay, so that comes in front of 25. So if you are going backwards, whenever you see a 25 in a whole square, the square root would contain a 0.5. Okay, so, or whenever you see a 25, the square root would contain a 5 as the last digit, and whatever is there in front of it, you just need to split it as A into A plus 1. So if I observe this carefully, I realize there's a 0.25 over here. So this would end in a 0.5. Okay, and 156 is actually 12 into 13. That is 12 into 12 plus 1. So the square root of this will simply have a 12. So I realize that this is 12.5. So AP turns out to be 12.5. Now if this part is clear, our first part of the question is done. That is, we found out all the lengths, and then comes the calculation of the trigonometric ratios. Okay, so before we go ahead, I'll erase a few initial steps, to make space for the solving of the trigonometric part. So once we found out all the lengths, now we can go ahead and calculate the tan. So this angle is theta, so this half angle is theta by 2. So tan of theta by 2, as we can see, is opposite upon adjacent. So that will be 5 upon 12.5. If you further simplify this, double it, so that becomes 10 upon 25. And cancelling out the 5, we get it as 2 by 5. So tan of theta by 2 is 2 upon 5. And if you know the tan of multiple angles, using tan of theta by 2, if I had to find tan of theta, that would be simply 2 times of tan of theta by 2 upon 1 minus tan square theta by 2. I've simply used the formula tan of 2a is 2 times tan of a upon 1 minus tan square a. Okay, so if I know this, I can simply substitute the value of tan theta by 2, that is 2 by 5. So 2 by 5 into 2. 2 tan theta by 2, the whole divided by 1 minus tan square theta by 2. So that is nothing but tan square of 2 by 5, that will be 4 by 25. And yeah, again I'll just erase a few initial steps to make more space. So I'm erasing the diagram as well, because we've done with that. We've understood that okay, the answer is going to be this calculation. So I'll just make space for this, and therefore this comes out to be 2 by 5, so that will be 4 by 5 the whole upon 21. 25 minus 4, that is 21 upon 25. 5 goes once, 5 goes 5 times. Denominator of denominator goes to the numerator, and 5 into 4, this becomes a 20 over 21. And therefore the answer to this question is option A. Right? Now as I realize, there is hardly any shortcut to this question. To be able to solve this question, you had to have clear understanding of coordinate geometry. You needed to have clear understanding of tan 2 theta based on tan theta. Okay, and if you were able to visualize the diagram, calculate the distances, only then you could have solved this question. So when you look at this question, you had to visualize, okay, there's an external point, there's a circle equation using which you'll find out the radius and the center, you find out the distance between the center and the point, and then using that you find out the length of the tangent, then calculate tan theta by 2, and then calculate tan theta. If you were able to make this link, you could have solved this question in the first go. It would have taken 2 to 3 minutes. And IPMAT Indore 2024 paper was slightly challenging in the QA MCQ section. Therefore, even if you are able to solve a question within 3 minutes, I would say it would be a type A or at max a type B question. Okay, so if you are clear with the concepts of these topics which were used over here, you should have attempted this question and you could have easily secured 4 marks in your IPMAT Indore MCQ paper.